So the last thing we're going to talk about in section 1.1 is the difference quotient. So given a function, which is y equals f of x, the inputs x and x plus h as long as h doesn't equal 0, so it's a little bit more than x, result in the images of f of x and f of x plus h. The quotient of their differences, also called the difference quotient, is as follows. If I take f of x plus h minus f of x over x plus h minus x, that's going to simplify down to f of x plus h minus f of x over h. It's important to note that this is a really important concept, especially for those of you taking calculus after this course, because it's used to define the derivative. So let's go through a few examples. So first I have a linear equation. I have f of x equals 4x plus 3. It's always important to kind of visualize what these functions look like. And what you're going to do is you're going to take f of x plus h minus f of x over h. This is the definition of the difference quotient. You're then substituting those values in for x in your function. So I have 4 times x plus h plus 3 minus, and I'm going to use parentheses to remind me to distribute that negative because that's where I see the most mistakes, 4x plus 3 all over h. And you should put an equal sign. Make sure you know it's an equality. That gives me 4x plus 4h plus 3 minus 4x minus 3 over h, which is going to simplify down because my like terms are going to cancel out. So I get 4h over h, which is 4. Now that's pretty interesting, right? Well, remember that this is a linear equation. So this is my slope, right? It's in y equals mx plus b form, and this is my y-intercept. So the difference quotient is actually also called, when it comes to linear equations, you might have called this the rate of change, which is just the slope. Now this only works for linear equations, but I just wanted to let you guys know that you have seen this before, so that's pretty cool. Now let's take a look at f of x equals 3 over x. Remember, this is a rational function, right? Its domain is all values such that its denominator doesn't equal 0. So this rational function's domain is x such that x doesn't equal 0, because if we substitute in 0 for x, we'd be dividing by 0, which is bad. I am going to go ahead and clear all of the space so I have room to work on this problem. Because it's a fraction, it's got a couple more steps. So I have f of x plus h minus f of x all over h equals 3 over x plus h minus 3 over x over h. Now in order to simplify this numerator, I need to find the least common multiple or lowest common divisor for our denominator. That's going to be x times x plus h. It's just those two factors. So I'm going to take my fraction on the left and multiply it by x on the top and the bottom. We do that to harness the power of 1. And this fraction on the right, I'm going to multiply by x plus h on the top and the bottom. That gives me 3x minus 3x minus 3h all over x times x plus h over h. Oh my gosh, this is a complex fraction. What we're going to do to simplify this is we're going to take our top fraction divided by our bottom fraction. So I'm going to have 3x minus 3x. Those are going to cancel. So I'm going to have a negative 3h over x times x plus h divided by h. Now remember, when we divide fractions, we keep the first fraction the same. We change from division to multiplication, and we flip the second fraction. So I get negative 3h over x times x plus h times h. Those h's cancel. And I am left with negative 3 over x times x plus h. Now here you see that the h remains in our answer, and that's okay. It can be there. It's not always going to cancel out like it does when we're working with linear equations, for example, in problem 1. Our last example is going to be a rational function. Remember, these look like half of I'm a little teapot. Just imagine my interpretive dance. I should post that too. YouTube. Okay, so what we're going to want to do in this case is rationalize all numerators. In order to simplify this, we need to rationalize the numerator. Typically, if we have a, and go ahead and clear this numerator. Typically, if I have a radical in the denominator, we don't like that, right? That's one of the things that make math professors go ew, right? Is radicals in the denominator. In order to solve this, you'd multiply by the conjugate. So the conjugate of the square root of x is just going to be the negative square root of x. This would be the conjugate. If I had 5 minus the square root of 2, the conjugate of this would be 5 plus the square root of 2. And it's called the conjugate because it uses what we know about the product of a sum and a difference in order to cancel out all the radicals. So let me show you what that would do. So let's say I had 5 minus 2 times 5 minus the square root of 2 times 5 plus the square root of 2. What you're going to see is our middle terms will cancel. I have 5 times 5, which is 25. I have plus 5 square root of 2 minus 5 square root of 2 plus the square root of 2 squared, which would just give me 2. So I have 25 plus 2, which is 27. We got rid of all the radicals. We rationalized them. In this case, we have to do this to the numerator, and let me show you why. All right, if I have f of x plus h minus f of x over h, that's the square root of x plus h minus the square root of x over h. And I can't simplify this any further. So now we're going to multiply by the conjugate of our numerator, which is just going to be, really, you just change the symbol. So I have the square root of x plus h plus the square root of x on the top and the bottom. That would give me the square root of x plus h squared minus the square root of x squared over h times the square root of x plus h plus the square root of x. So exciting. So my numerator becomes x plus h minus x, which is going to simplify to h. And then I have h square root of x plus h plus square root of x. So we get h over square root of x plus h plus the square root of x times h. Those h's cancel. And I have 1 over the square root of x plus h plus the square root of x. And this is okay. It's okay to leave it in this form. Even though we have radicals in the denominator, and I said that's something we typically don't like, we need to leave it in this form because if we multiplied by the conjugate again, which would be this guy, right, that would be the conjugate, we'd just undo everything we did. So this is going to be the simplified form.